Welcome to lesson 6 of this course. In this lesson we'll learn how to evaluate deep learning models in Pytorch. Let's go to Colab. Now we're on Colab. Now that we've trained our model in the previous lesson, we should try to evaluate it on the test data. We're going to import the necessary libraries and import the data and make data loaders out of it. Then we're going to create the model. We've explained this code, so we won't go into it deeply. Then this is the important part of today's lesson. This is the evaluate function, and we'll give this model batches of our data and the model, and it's going to evaluate the model on the batches that we give it. This function will give an accuracy out of 1, so it's either 0 or any number in between, or 1 for the accuracy. Okay, so first we have a decorator, torch.nograd. This disables the gradient calculation, which reduces memory consumption, because during training we need to calculate the gradient, so we go down the loss curve so that we have a lower loss. Then we call model.eval, which tells the model that we'll start evaluating, as the model behaves differently during training and evaluation. During evaluation there might be some features that aren't present during evaluation. For example, .eval deactivates dropout layers which are needed during training. Then we divide the data into images and labels. Then we produce outputs out of the images. Then we call torch.max. This max function returns the maximum value given a tensor and the dimension that we need to look at. So we look at each the outputs for the model on each image. Then we take the indexes and store that in preds. And when we store that in preds, we see how many values did we get correctly. So we write preds equals labels. This will produce a tensor filled with trues and falses. Where it's filled true, we guessed correctly, and wherever it's false, we've guessed incorrectly. Then we sum the amount of trues in the tensor. And this function returns a number, but in a tensor, so we call .item to return a number. And then we divide that number by the length of predictions that we've made to get the average, to get the accuracy that we've made on the batches. Then we need to call this function on all the data set. So we make a list called batches scores, which will contain the numbers that are the accuracies of each batch. Then we'll average this number. So we go through the test loader batch by batch. Then we evaluate the model. Then we append the number that we get, the accuracy, to the list batches scores. Then we get the mean by converting the batches scores variable into a tensor. Then we call torch.mean to get the mean. Then after we got the mean, we call .item, the method, so that we can get a number, and this will be the overall accuracy. Our model has finished evaluating on the test set. So now we have the overall accuracy in this variable called overall accuracy. Let's see the overall accuracy. We get around 10%, which is obvious because we didn't train the model, and it should get around 10% because there are 10 classes and we predict randomly. In today's lesson we've learned how to evaluate our model. As we trained and evaluated our model, let's start making single predictions on it and save the model so that we can use it in another time. See you next lesson.